awak yang tu lah. Jangan lupa subscribe channel kita, tanda sokongan. Terima kasih. Alright, Assalamualaikum and hi everyone. So dalam video kali ini kita akan discuss jawapan bagi set Skor A Fizik 2022-2023. Jadi ini merupakan set yang keenam yang telah saya discusskan dalam channel ini bagi sesi 2022-2023. Alright, so now let's start with the first question. So given two vectors P and Q as shown in figure 1 here, if the magnitude of P and Q is 40 Newton and Q is 20 Newton, so calculate the magnitude of the resultant force. So here we want to calculate the resultant force. So in this case, we have P is equal to 40 Newton. So let's write. So here is 40. And then Q is equal to 20 Newton. Alright, so in order to calculate the magnitude of the resultant force, so the question states that we want the magnitude only, so no need to calculate the direction. So the magnitude is in this direction. Okay, so F is equal to, so in order to calculate the magnitude of the resultant force, it is equal to, okay, the force in X component, which is P squared plus Q squared. Okay, so take the square root. So P is equal to 40, okay, so 20, so that one is 20 squared, okay. So kalau kita tengok pada direction, so you can see here that the direction of Q is downward direction. So kalau you letak this one, you letak negative pun tak ada masalah lah, okay, negative 20 squared, still you have the positive answer, okay. So finally, the magnitude of the force is equal to 44.72 Newton, okay. So this is the answer for question number 1. Alright, so now let's proceed to question number 2. So 2A, so here we have AT graph, acceleration against time graph for a moving object. So the object has an initial velocity u equal to -4 meter per second at t is equal to 0 second. And at the same time, from the graph here, we can see that the acceleration when t is equal to 0 second is equal to 2 meter per second squared. So untuk jawab soalan yang pertama, okay, so calculate the time when the velocity is equal to 2 meter per second. So means that u is equal to -4 meter per second and then v is equal to 2 meter per second. So from the graph, we have information about acceleration. At t is equal to 0 second, acceleration is equal to 2 meter per second squared. Alright, so in order to calculate the time when the velocity is equal to 2 meter per second, so we can straightly use equation v is equal to u plus at. So this is very simple. Since we have value of v here is 2 and then u is -4 plus the acceleration is 2 and then finally we can find t, where t is equal to, so we have t is equal to 3 seconds. Okay, so this is the answer. And then for second part, so we want to sketch a graph of velocity against time to describe the motion of this object. Okay, first of all, look at the timeline here. So this is from 0 to 4 seconds. Okay, so from 0 to 4 seconds and this is 4 to 8 seconds. So from 0 to 4 seconds, so remember that the initial velocity is equal to -4 meter per second at t is equal to 0 second. Okay, so maknanya u dia mula daripada -4 meter per second. And then we can see here from, okay, so you can see here that from 0 to 4 second, that the acceleration is constant, where A is equal to 2 meter per second squared. From 0 to 4 second, okay, A is equal to 2 meter per second squared. And then now we can calculate what is the velocity at 4 second. So at 4 second, at t is equal to 4 second, we can calculate what is v, where it is equal to u plus at. Okay, so v is equal to -4 plus a is 2 and the time is 4 second. Okay, so means that the final velocity after 4 second is equal to 4 meter per second. So means that the object start at -4 meter per second, and then after 4 second the velocity reach 4 meter per second. So ini maklumat yang pertama yang kita ada lah. Okay, and then from 4 to 8 seconds. Okay, from 4 to 8 seconds, so the acceleration is equal to -2 meter per second squared. Alright, so means that we can calculate what is the velocity at 8 second. Okay, so at 8 second, at t is equal to 8 second, okay, we actually can find what is the velocity. Okay, where velocity is equal to, where v is equal to u plus at. Alright, and then we can calculate v if the initial velocity at 4 second tadi adalah 4 plus 2, and then from 4 to 8 second is equal to 4 second. This one should be negative, right? Okay, so means that velocity, okay, at 8 second is equal to -4 meter per second. Alright, so now let's try to sketch the graph. So let's say here we have v in meter per second, and then here we have t, the time in second, and start from 0. So we're going to have 0 to 4 seconds, and then 6, and this is 8 seconds. Okay, so the initial velocity is start from -4. Alright, so let's say here is -4, and this is 4 seconds. Okay, so at t is equal to 0 second, okay, so means that the initial velocity is -4. And then at t is equal to 4 second, okay, yang kita kira tadi, okay, v is 4 meter per second. Okay, so means that at 4 second, v is equal to this one. Okay, v is equal to 4 meter per second. And then at t is equal to 8 second, alright, at t is equal to 8 second here, velocity is -4 meter per second. So the velocity is equal to -4. Okay, so means that here. Okay, so kalau kita tengok daripada graph acceleration kat sini, okay, awak boleh nampak from 0 to 4 second, acceleration dia constant. Okay, so acceleration is constant, which is a is positive. Alright, so a is positive, so means that graph, kita punya graph velocity kita mesti macam ini. Okay, so this is the positive value of gradient. Okay, jadi kalau graph VT mesti gradient dia macam ni lah. Tapi kalau acceleration kita negative, so pattern of the graph macam ini, showing that the gradient of the graph is negative. So negative value of the gradient. Okay, kalau kita nak kira what is the velocity at 2 second pun boleh sebenarnya. Okay, kalau kita nak tahu at t is equal to 2 second, if the acceleration is constant 2 meter per second, actually we can calculate what is the velocity at 2 second. Sama juga, you can use v equal to u plus at. So u is equal to -4 plus a is 2 and the time is 2. So actually at t is equal to 2 second, you akan dapat v dia adalah 0 meter per second. Okay, at this position. Ataupun from 4 to 8 second you nak kira. Masa 6 second you nak kira juga. So you can show. Okay, saya tulis kat bawah ni lah. So at t is equal to 6 second, acceleration is -2 meter per second. Okay. So kalau you nak kira juga, contohlah kita nak guna v is equal to u plus at. So u dia kita ambil daripada, let's say lah you nak ambil daripada sini pun boleh. Kan? Daripada sini, kalau you nak ambil daripada sini, initial velocity should be 4. And then the time it should be 2 seconds, 6 minus 4. And then kat sini saya akan masukkan u dia adalah 4 plus -2. And then saya nak kira what is the velocity masa dekat 6 second. So 6 minus 4, 2 second. So saya masukkan dekat sini 2. So saya akan dapat juga 0 meter per second. Okay, so akan 2 lah. Maknanya at t is equal to 2 second. And this is at t is equal to 6 second. Pun 0 juga. So kalau kita masukkan dekat sini. Jadi bila you sketch your graph. Okay, let's say here. Okay, we have a ruler. And then you try to sketch your graph. Adjust line. So, something like this. Okay, sama juga macam ini. From 4 to 8 second. Okay. Maknanya kita nak tahu V dia kosong masa bila. So, bila kita kira V dia kosong adalah ketika 6 second. Okay, so macam itu. Okay, so this is the answer for question 2A, 1 and 2. Okay, so this is the graph for question 2A2. Okay, so finish question number 2A. So now let's proceed to question 2B. Alright, question 2B. So here we have an arrow which is 2.5 meter from the ground. So let's say this is the ground. So it is 2.5 meter from the ground. So the launching point is here. Okay, so this is the launching point. Okay, and the initial velocity is given 25 meter per second at angle of 40 degree to the horizontal. Means that you need to resolve first u into ux and uy. Okay, and then the position of the launching point here is 20 meter away. Okay, 20 meter away from the wall. So here we have a wall which is 20 meter away from the launching point. At what height from the ground does the arrow hit the wall? So first of all, let's try to resolve first ux and uy. So here we have ux. Okay, awak tengok pada angle tu duduk sebelah x kan? So bila duduk sebelah, dia akan jadi cos. So which is 25 cos 40. And then this is uy, which is 25 sin 40. Okay, and then we try to take out all the informations given. Okay, so here we have sx is equal to 20 meter. So now we want to calculate what is the height from the ground does the arrow hit the wall. Jadi kita nak tahulah daripada sini. Okay, dan dia akan sampai dekat sini where the horizontal displacement is 20 meter. So daripada maklumat horizontal displacement, actually we can find, okay, what is the time taken, masa yang diambil untuk arrow itu sampai dekat wall tadi daripada launching point. So sebab kita ada maklumat sx which is 20 meter, ux is equal to 25 cos 40. Okay, so kalau kita tekan calculator, masa yang diambil daripada launching point dekat sini tadi sampai dia terkena pada dinding which is 20 meter away from the launching point, it is equal to 1.04 second. Okay, jadi sekarang saya nak kira dia punya sy. Maknanya when sx is equal to 20 meter, saya nak tahu sy dia tu dia berada pada vertical displacement berapa sini. Jadi saya nak kira. So kalau saya nak kira, saya akan guna sy is equal to uyt minus half gt squared. Jadi kita tahu tadi masa yang diambil daripada launching point ke dinding tadi adalah, okay, t is equal to 1.04 second. So daripada sini saya boleh kira lah SY. So 25 sin 40. Alright. And then T is 1.04 minus half 9.81 T squared is 1.04 squared. Okay. So you tekan kalkulator elok-elok. So you akan dapat 11.4 meter. So 11.4 meter adalah, that one is positive, right? So 11.4 meter is the vertical displacement. Okay, that one is the vertical displacement. Okay. Jadi 11.4 meter ni dia adalah positif. Kalau saya nak kira the maximum height, let's say lah I want to calculate the maximum height, okay, that reached by the arrow. So saya akan kira SY, so saya akan guna VY squared, alright, equal to UY squared minus 2G SY. So in case saya nak kira the maximum height SY maximum, so VY at maximum height should be 0, and then UY is 25 sin 40 squared minus 2 9.81 SY maximum. Okay, so therefore the maximum height is equal to 13.16 meter. Okay. So maknanya daripada kiraan maximum height tu saya dapat tahu yang objek itu belum sampai lagi maximum height. Okay. Maksudnya yang kita kira tadi 20 meter. Okay. When the horizontal displacement is 20 meter, the vertical displacement SY is 11.4, which is less than 13.16. Okay. So maknanya kalau dia naik atas, ni maknanya dia belum sampai lagi. Dia belum sampai lagi dia punya maximum height. So means that bila dia sampai dekat dinding tu, dia belum reach lagi maximum height. Mungkin maximum height dia lagi tinggi lah. Okay, which is kita kira tadi 13.16. So maknanya ketinggian yang kita kira tadi 11.4 meter is actually this one. Okay, positif kenapa dia positif? Sebab dia masih bergerak naik ke atas. Direction dia still upward direction. So this one should be positive 11.4 meter. Okay. Jadi bila dia nak from the ground, so kita kena tambah lah lagi 2.5 meter. Ingat So maknanya arrow tu tadi from the launching point, dia masih bergerak ke atas. Dia belum sampai lagi maximum height 13.16 meter. Dia tak ada pun turun ke bawah ke, tak ada. Okay. So maknanya dia naik ke sini and then arrow dia terus kena kat sini. So which is 11.4 meter. Okay, kalau mungkin dinding ni tak ada, dia akan terus lagi bergerak sampai maximum height 13.16 meter. So therefore, the height, okay, from the ground, okay, is actually equal to, okay, 11.4 meter plus 2.5 meter. Okay, therefore, the answer is 13.9 meter. Okay. 13.9 meter. Okay. So 13.9 meter is the answer. Jadi saya kira maximum height dekat sini hanya untuk tunjuk dekat awak di mana arrow itu naik ke atas. Dia belum sampai lagi maximum height. So means that arrow itu belum sampai maximum height. Kalau dia dah sampai maximum height, maknanya perjalanan arrow tu sudah turun ke bawah. Okay. So jadi positive 11.4. Okay, showing that the arrow is moving upward, still moving upward, and this is 11.4 meter from the launching point. Bila kita kira SY, dia mesti pada level mana dia dilepaskan. Okay, iaitu launching point dia ke tempat arrow itu kena tadilah. So 11.4. Jadi jawapan dia bukan 11.4. So kita kena tambah dulu dengan 2.5 meter from the ground. Okay, so the answer is 13.9 meter. Alright, so now finish question number 2. So let's proceed to question number 3. Alright, now question number 3, and this is about impulse. Okay, so 3A, a 20-gram ball falls and hits the floor with a speed of 5 meter per second. The ball rebounds with a speed of 4 meter per second. Calculate the impulse and the impulsive force if the time of contact, okay, is 0.3 second. Okay, so means that, let's say, so this is the floor. Okay, so this is the ball, and let's say it's moving downward. Okay, so before collision between the ball and the floor is equal to -5 meter per second. Why negative? Sebab direction dia adalah downward. Okay, so this is because of downward direction. And then what happened after collision? So the ball is moving upward. So V is equal to +4 meter per second. Okay, and then the contact time between the ball and the floor is given, which is T. Maknanya adalah time contact tu antara siapa? Antara bola tu dan juga lantai tadi, very small, and it is equal to, so delta T is equal to 0.3 second. Okay, so we want to calculate impulse. You check dekat depan, equation impulse equal to F delta T, okay, ataupun impulse juga equal to delta P, where it is equal to mv minus mu. Okay, so kalau kita nak kira the impulse, so the first one we can calculate the change of the momentum mv minus mu, sebab kita dah ada nilai v dan juga nilai u. Okay, and then let's substitute the mass. So the mass is in gram. Make sure you change to kg. 20 gram, which is 20 times 10 power of -3 kilogram. Okay, ataupun you boleh 20, 1, 2, 3. So means that 0.02 kg. Okay, so V is given 4. Okay, minus, so U is -5. Remember to put negative, that is very important. So because the direction of U is downward, so you must put the negative in your calculation. Okay, so impulse is equal to 0.18. Okay, make sure you put the correct unit. And then we want to calculate the impulsive force. Remember, we have a second equation. Okay, J is equal to F delta T. So F is equal to 0.18 Newton second over the contact time, which is 0.3. And finally, the answer is equal to 0.6 Newton. So this is the answer for question 3A. Alright, now question 3B. So we have figure 4 here, shows a 2 kg box X. So the mass of X is 2 kg. It's placed on a rough horizontal surface. So means that there is a frictional force between box X and the surface. It is attached to another box Y by a massless string. When the weight of box Y is slowly increased to 6 Newton, X is about to slide. Alright, so this is very interesting question. So let's sketch the free body diagram first for box X. Alright, so now for question number 1, so for the free body diagram, so let's sketch first all the forces on box X. Okay, so obviously we're going to have normal force and weight, okay, X, and then the frictional force, okay, the static frictional force. Okay, macam mana kita nak tahu static frictional force tu ke mana? So we just imagine if the weight of box Y increase, so box X will start to move to the right. Okay, means that the static frictional force should be to the left. Okay, and here we have T, okay, which is the string. So now let's sketch on the free body diagram. So here we have the Y component, and this is the X component. Okay, so Y component and X component. So this is the object. So first force is the normal force, and then weight Wx, and then the tension T, and the last one is static frictional force. Sebab dia tidak bergerak kan? Okay, and then determine the coefficient of static friction. So we want to determine the coefficient of static friction, which is mu s here, where Fs is equal to mu Sn. Okay, so now in order to calculate the static frictional force, so let's try to write total Fx, okay, is equal to 0. So now this is for box X. So there are two forces, T and also the static frictional force. So kita tulis dekat sini lah, T plus negative static frictional force is equal to 0. So in this case, we want to find what is the mu s. Okay. N tu kita boleh cari lah. N tu kita ada masalah. N tu kita boleh dapat daripada Y component. Okay. So where Y component for box X is also equal to 0. Where N plus negative W weight of X. So now where N is equal to mass of box X times G. Okay, so in order to calculate mu S, okay, actually we need to find first what is the tension T. Okay, where N here is mxg. Jadi semua maklumat ni kita ada. G, mx, mu ni kita nak cari. Okay, tapi kita tak ada nilai T. Jadi macam mana kita nak dapatkan nilai T? So now let's proceed to another part where at this point, this is actually equilibrium. Okay, means that kita boleh lukis this point. Okay, kita akan ada T1. And then ini tadi adalah T. And then at this point, dia akan ada satu pemberat tadilah yang kita tambah. Iaitu weight of box Y. Okay, so jadi soalan bagi tahu kita tadi, when the weight of box Y is increasing until 6 Newton, then box X is about to move. Dia baru mula hendak bergerak. Okay, ada ayat dia tadi. Okay, X is about to slide. Okay, means that at this point, when X is about to slide, okay, the static frictional force is maximum. Okay, that's why kita gunalah WY is equal to 6 Newton. So, kita nak dapatkan tension, kita gunakan maklumat dekat sini. Okay, in order to calculate tension. So now let's start to draw the free body diagram for the second part. Okay, so here we're going to have T1, where T1 is here, means that the angle, so this is the y-axis and this is the x-axis. So maknanya dekat sini adalah 30 degree. So kita boleh letak dekat sini 30 degree. Okay, and then kita akan ada WY. Okay, so WY is equal to 6 Newton. And then kita akan ada T. T tu yang kita nak cari lah. Okay, jadi this is equilibrium. Okay, so this is equilibrium. Okay, so maknanya kita consider total Fx equal to 0. Total Fy also equal to 0. So untuk X component, kita kena resolve pula ini kepada T1X. Dan ini kepada T1Y. Okay, so dia akan jadi T1X minus T equal to 0. Where T1X is actually T1 cos 30 degree minus T is equal to 0. Jadi kalau kita nak kira T ni, dia adalah T is equal to T1 cos 30 degree. But we still cannot solve for this one, right? Okay, so we let it as equation number 1. Kenapa? Sebab kita tak ada nilai T1. So now let's proceed to the second component, which is Y component. Okay, so in Y component sama juga ada dua force T1Y dan juga WY. Okay, so this is very easy. Where T1Y, okay, minus WY equal to 0. So T1Y is T1 sine 30 degree equal to WY, which is 6. So from here, actually you can calculate TY is 6 over sine 30 degree and T1 is equal to 12 Newton. Okay, so number 2. So T1 dah dapat nilai. Therefore, we can get tension of the string T is equal to T1 cos 30. T1 tadi adalah 12 cos 30. So, akhirnya saya dapat T dekat situ adalah 10.4 Newton. Tapi belum menjawab soalan di mana 10.4 Newton ini, T ni tadi, kita nak guna untuk cari kita punya mu. Okay, so kita nak kira mu. Therefore, mu S is equal to tension 10.4 over mass of box X, which is 2 kg times 9.81. Okay, when we substitute the values, So mu s is equal to 0.53. Tak ada unit ya. So no unit for coefficient of static friction. Alright, so now finish questions 3b. Okay, so let's proceed to questions 3c. Alright, question 3c. So a 20 kg block is pulled to the right by a force of 200 Newton at a constant acceleration on a horizontal rough surface. Okay, so means that here we have a rough surface and this is the block and it is pulled to the right by the external force which is 200 Newton. Okay, and a constant acceleration. So means that there is a frictional force Fk where the coefficient of kinetic friction is given. Okay, mu k is 0.6. Okay, so we want to calculate the acceleration. So the object will move in this direction, right? So this is very simple. We can just use equation. Total force in x component is equal to ma. Okay, so A dia bukan kosong lah, dia minta kita kira A. Okay, acceleration is constant, not velocity is constant. Okay, so the object is moving in x component, so total Fx equal to ma. So we're going to have F1 plus the kinetic friction is equal to negative Fk equal to ma. And then F1 is 200, we can straightly substitute, minus mu n. So mu is 0.6. But we're going to have normal force from the y component. Okay, remember? Okay, so the free body diagram, the normal force is upward and we're going to have weight. And we're going to have weight. So the total Fy, so object tidak bergerak in y component. So n plus negative w equal to 0. So n is equal to w, which is equal to mg. Okay, so now we can straightly substitute 200 minus 0.6. Okay, and then mg, and the mass is 20. Normal force tadi ini mg. Okay, so times 9.81 ma, where the mass is 20 kg. Acceleration kita nak cari. Okay, and finally acceleration is equal to 4.11 meter per second squared. Okay, so this is the answer. See you in the next session. Don't forget to like, share and subscribe channel Madam Fika Fiki. Jumpa lagi. Assalamualaikum dan selamat sejahtera.